Assalamualaikum and hello everyone. My name is Izzah Nur Atika from Group 6 and I'm going to tell about our topic, which is electric vehicle battery handling and maintenance in industrial processes. The study of industrial processes involve understanding the systematic series of actions and operations that convert raw materials into finished products. This process is essential for producing a wide range of goods, from consumer products to industrial machinery, and plays a critical role in economic development and job creation. Industrial processes are characterized by their reliance on technology, machinery, and labor to transform inputs into outputs efficiently. They are essential for enabling mass production, reducing costs, and increasing product availability.
Hi and Assalamualaikum. My name is Siti Hajar and I'm gonna talk about hazard in EV battery handling and maintenance. We have 5 hazard, which is biological hazard, physical hazard, chemical hazard, physiological hazard, and agronomic. Biological hazard. Microbial growth on used battery. Improper storage of used or damaged EV batteries in damp or dirty area can cause mold or bacteria to grow on the battery casing, increasing the risk of contamination. Flood-exposed battery contamination. Batteries taken from vehicles that pass through flood water may carry microorganisms and harmful contaminants stuck to the surface. Now we move to physical hazard. High voltage shock breaks. Contact with exposed high voltage component during inspection or repair can result in electric shock or severe burns. Thermal runaway and fire. A damaged or overheated lithium-ion battery can rapidly increase in temperature, causing fire or explosion. Chemical hazard. Toxic gas release. Overheating or burning batteries can release harmful gases such as hydrogen fluoride, which irritate the eye, skin, and respiratory system. Electrolyte leakage. Damaged battery cell may leak corrosive electrolyte fluid that can cause skin burn and chemical irritation. Physical hazard. Pressure to avoid mistakes. The high cost of EV batteries can create mental pressure, leading to stress and reduced focus. Long hours and fatigue. Extended maintenance tasks and constant attention to safety can cause mental exhaustion. Ergonomic hazard. Manual lifting of heavy battery packs. Handling large and heavy EV batteries without lifting device can strain the back, shoulder, and wrist. Awkward working position. Installing or removing batteries in tight vehicle components may force workers into unsafe postures. Repetitive maintenance tasks. Performing repeated movements during inspection or assembly increase the risk of musculoskeletal disorders.
Hi, my name is Nur Ali Maisara, and now I will talk about risk assessment. By using risk metrics, it can help us evaluate hazards by looking at 2 main factors, which is likelihood and severity. Likelihood tells us how often an incident might happen. A rating of 1 means the event is almost impossible, while a rating of 5 means it is most likely to occur and may happen frequently. The ratings in between range from remote to conceivable to possible, depending on how common the event could be. Severity shows how serious the outcome would be if the incident happens. A rating of 1 indicates minor or negligible effects, such as small cuts or minimal damage. Meanwhile, a rating of 5 represents catastrophic consequences, which may include multiple fatalities or major system failure. To determine the level of risk, we multiply the likelihood and severity scores. The result fits into a color-coded category, which is green for low risk, yellow for medium risk, orange for high risk, and red for very high or extreme risk. This metric helps us identify which hazard require immediate action and which ones can be managed with regular monitoring. It ensures that we focus our control measures on the most serious and most likely risks to maintain a safer working environment. Now, let's talk about HIRAC. HIRAC summarizes the key hazards and controls for all high voltage battery operations. We assess 5 main activities, which is preparation and de-energization, physical battery removal or installation, battery disconnection, handling damaged or leaky batteries, and long-term battery storage. The major hazards include electric shock, severe burns, fire risk, crushing injuries during lifting, chemical exposure from leaking electrolyte, and thermal-related fire hazard during storage. Based on our risk matrix, the highest risk come from high voltage work and lifting related tasks, which fall into the red and yellow zones. To control this risk, we require insulated tools, proper warning sign, electrical safety training, and standard lifting procedure. For damaged batteries, D-class extinguishers and chemical PPE are mandatory. Storage risk is low when batteries are kept in a designated temperature control area. Overall, implementing these controls keep the task within acceptable risk level, ensuring safe and compliant operations.
Assalamualaikum and hi, my name is Nurani Suraya binti Amban. I'll be presenting about the control measures, biological hazards, administrative controls, housekeeping, maintaining a clean facility and good hygiene practice, waste management, proper management and disposal of any biohazardous waste according to local regulations. Second one will be chemical hazard, engineering controls, ventilation system, educate general and local exhaust ventilation in manufacturing, charging and storage area to manage routing of gassing and potential fumes from damaged batteries. Administrative controls, safety data sheet SDS, making SDS for all chemical readily available and ensuring workers are trained on their content. Physical hazard, engineering controls, protective casing and barriers. Designing batteries with robust protective casing and physical barriers prevent direct contact with live part. Administrative control, safe work procedures, implementing strict procedures for working on or around high voltage system, including verifying the absence of voltage before work and proper lockout, takeout, LOTO protocols. Move on to the next part, psychological hazard, administrative controls, training and education. Comprehensive safety training builds worker confidence and reduces anxiety related to handling complex, high-power system. Clear procedures, developing clear standard operating procedures and providing access to manufacturer-specific information for tasks. The last one will be ergonomic hazard, engineering controls, automation, utilizing robotic arms and automated assembly lines to perform repetitive or forceful tasks, and administrative controls, ergonomic assessment, performing regular ergonomic assessment of workstation and tasks. For conclusion, proper control of hazards related to EV batteries is essential to protect workers, prevent accidents, and maintain a safe working environment. By implementing effective physical, chemical, biological, psychological, and ergonomic hazard control measures, organizations can significantly reduce the risks of fire, toxic exposure, electric shock, stress, and musculoskeletal injuries. Consistent use of safe work procedures, engineering control, proper storage, regular training, and appropriate personal protective equipment (PPE) ensures safer handling, storage, and maintenance of EV batteries, and help promote a strong workplace safety culture.
And lastly, the main goal is to ensure effective electric vehicle battery safety. All personnel must be qualified and trained to work in a clean, isolated workspace using specialized personal protective equipment and tools. Strictly following the 5 safety rules for isolation, lockout, or takeout, carefully preventing mechanical and thermal damage, and maintaining a coordinated emergency response plan.